Hey tech lovers, welcome to the Gadget Facts, your go-to channel for understanding the fascinating world of technology. Today, in this video, we explore the fascinating technology behind 3D printers and how they are manufactured in factories. Learn about the different types of 3D printing, including FDM, SLA, and SLS, and see the step-by-step process of how these innovative machines are made, perfect for tech enthusiasts and those curious about modern manufacturing processes. Let's dive in. We live in a world of 3 dimensions. We experience objects not just as flat images, but as tangible things with depth, texture, and form. For centuries, we've been limited to creating in 2 dimensions. But what if we could build objects directly in 3 dimensions, like a sculptor molding clay but with the precision of a machine? Enter the 3-dimensional printer, revolutionizing design, prototyping, and manufacturing. This is the reality of additive manufacturing, changing the world. Instead of ink, 3-dimensional printers use materials like plastic, metal, or even chocolate. They build objects layer by layer, following digital blueprints to create anything. This technology is now accessible to businesses and individuals alike. Imagine a cake being built layer by layer, each layer carefully spread and stacked upon the last. That's a simplified way to envision how 3-dimensional printing works. It starts with a digital 3-dimensional model, like a blueprint made using computer-aided design software. This model is then sliced into hundreds, sometimes thousands of thin, digital cross-sections. These slices are the instructions for the 3-dimensional printer. The 3-dimensional printer, following these digital slices, lays down material layer by layer, building the object from the bottom up. Each layer bonds with the one below it, slowly transforming the digital blueprint into a tangible object. The precision is astounding, often measured in microns, which is smaller than the width of a human hair. It's this level of detail and control that makes 3-dimensional printing so revolutionary, opening up a world of possibilities for customization and complexity that traditional manufacturing methods simply can't. Among the various 3-dimensional printing technologies, fused deposition modeling stands as the most widely recognized and accessible method. Imagine a hot glue gun, extruding a continuous strand of melted plastic, guided with pinpoint accuracy by a robotic arm. That's fused deposition modeling in a nutshell. It's the workhorse of the 3-dimensional printing world, known for its simplicity, affordability, and versatility. Fused deposition modeling printers utilize a thermoplastic filament, a thin plastic thread wound around a spool much like a fishing line. The filament is fed into a heated nozzle, melting it into a semi-liquid state. The nozzle then precisely deposits this molten plastic onto the build platform, tracing the contours of each layer according to the digital instructions. As layers stack upon layers, the object gradually takes shape, solidifying as it cools. Fused deposition modeling printing is like watching a sculptor meticulously build a masterpiece, layer by painstaking. While fused deposition modeling excels in accessibility and versatility, stereolithography reigns supreme in precision and surface finish. Imagine a vat filled with liquid resin, sensitive to ultraviolet light, and a laser beam precisely tracing patterns on its surface. This, in essence, is how stereolithography 3-dimensional printing works. It's the go-to technology for applications demanding intricate details and smooth, high-resolution surfaces. Stereolithography printers utilize a process called photopolymerization, using a UV laser to selectively cure a liquid photopolymer resin. The process starts with a platform submerged in the resin vat. The UV laser then traces the shape of each layer onto the resin surface, curing and solidifying the exposed areas. The platform then lowers incrementally, submerging the newly formed layer, and the process repeats. Layer by layer, the object rises from the resin bath, boasting intricate details and a smooth, almost polished finish. Stereolithography printing is like developing a photograph in 3 dimensions, using light to solidify a liquid into a solid. Selective laser sintering, or SLS, forging strength from powder. SLS fuses powdered materials using a high-powered laser. A laser beam selectively melts and fuses powder particles. This is SLS printing. It creates strong, durable parts from various materials. SLS is like sculpting with powdered. Section 6. Building the Dream. A look inside 3D printer manufacturing. The magic of 3D printing extends beyond the objects they create. It's equally fascinating to peek behind the curtain and understand how these incredible machines are made. Just like the devices they produce, 3D printers themselves are a testament to precision engineering and meticulous assembly. From sourcing components to final testing, the manufacturing process is a symphony of technology and human expertise. The journey begins with sourcing high-quality components. Motors, linear rails, control boards, power supplies. Each element plays a critical role in the printer's performance. These components arrive from various specialized manufacturers, each a testament to the interconnected nature of modern manufacturing. It's like gathering the finest ingredients before embarking on a culinary masterpiece. Each component contributes to the final product's functionality and reliability. Section 7. From components to cohesion. Assembling the 3D printing powerhouse. With components sourced and quality checked, the assembly process begins, transforming individual parts into a cohesive, high-precision machine. Skilled technicians, armed with specialized tools and meticulous attention to detail, bring the 3D printer to life. It's a carefully choreographed ballet of mechanical assembly and electronic integration. The process often starts with the frame, the backbone of the 3D printer. Whether it's a sturdy aluminum extrusion or a sleek, molded plastic chassis, the frame provides the structural integrity upon which all other components are mounted. Linear rails, responsible for the smooth and precise movement of the printhead, are carefully aligned and secured. Motors, the driving force behind the printer's movements, are mounted and wired, their whirring hum a testament to the machine's coming alive. Section 8. Breathing life into the machine. Electronics installation and calibration. With the mechanical assembly complete, it's time to breathe life into the machine through the intricate world of electronics. Control boards, laden with microchips and circuitry, are installed, connecting the printer's brain to its mechanical muscles. Wiring harnesses, carrying signals and power, are meticulously routed and connected, ensuring flawless communication between various components. Calibration is the final crucial step, ensuring the printer operates with pinpoint accuracy. Using precision measuring tools and sophisticated software, technicians fine-tune the printer's movements, ensuring the printhead deposits material with micron-level precision. It's like tuning a musical instrument, ensuring each note is pitch-perfect. Except in this case, the instrument builds objects instead of playing melody. Section 9. Ensuring excellence, the crucial role of quality control in 3D printing. Before a 3D printer leaves the factory floor, it undergoes rigorous testing and quality control procedures. Every aspect, from print quality to mechanical accuracy, is meticulously scrutinized. It's this unwavering commitment to quality that ensures these machines deliver on their promise of precision and reliability. Test prints are run, pushing the printer to its limits, evaluating its ability to produce intricate details, smooth surfaces, and strong, dimensionally accurate parts. These tests aren't just a formality, they are a testament to the manufacturer's commitment to excellence, ensuring that every 3D printer that leaves the factory is ready to turn digital dreams into tangible realities. 3D printers are remarkable machines that revolutionize the way we create objects. Understanding how they work and how they are made gives us a deeper appreciation for the technology. We hope you enjoyed this journey into the world of 3D printing. Don't forget to like, share, and subscribe to the Gadget Facts for more exciting insights into the world of technology. If you have any questions or topics you'd like us to cover, leave a comment below. Thanks for watching.